Yeah. What did you learn from there? The fluorescence. Or any challenges, any problem that you faced during the experiments?
Apa yang saya ingat, kita guna bahan tu, lepas tu dia ada mirror kot. Lepas tu daripada kiri dia pancar ke kanan. Lepas tu keluarlah dia punya absorbance. Lepas tu kita punya absorbance yang betul-betul punya semakin turun ke semakin meninggi. Macam tu lah. Saya tak ingat dah.
Apa?
Kalau concentration semakin tinggi, absorbance dia semakin rendah kan ayahanda?
Manalah yang dia tahu. Tak, okay, but you did notice one thing just now, the mirror image.
Yeah.
Okay, the mirror image actually could be one of the characteristic, of fluorescence, yeah. Okay, mirror image between the absorption and also the emission. Okay, thank you, Farah. Is there any other observations? Okay, regarding the experiment. Okay, because experiment too actually we do in purpose. Okay, actually the learning process is need to go hands in hand, okay, between the theory that we learn in the class and also the practical, okay, that we learn in the lab. Okay, you cannot just simply doing the experiment and then you forgot everything. Okay, this is not the case. Jadi kalau kita belajar kerana Allah SWT, that's not the right attitude. Okay, maybe can I hear something from Siti Hazwani? Siti Hazwani? Cepat-cepat sikit so respon cepat sikit sebab nanti kita tak ada masa ni. Okay, Siti Hazwani, are you there?
Yes, doctor.
Yes, okay. What you learn, from the experiment?
From the experiment,
From the
we
fluorescence
can learn
experiment.
about intensity, emission, and intensity. Emission intensity from the experiment, we can learn the emission intensity of light.
Emission intensity of light? What did you learn about it? Okay. What did you learn about the emission intensity of light? Which light you are referring to? Emission ni apa sebenarnya? What's emission? Emission to stand for what?
Emission which caused by excitation of atom.
Okay, excitation of atom, and then excitation of atom, okay. Excitation atom tu apa yang berlaku? What happening during excitation? Ada siapa yang boleh bantu Hazwan ni? Okay. I just want to gauge, your understanding on the experiment. Okay, Azwadi, they mentioned about the emission, they mentioned about the light intensity, you mentioned about excitation. What is excitation? What is the difference between excitation and emission? Azwani, can you answer that? The difference between excitation and emissions.
Ayahanda, saya nak jawab boleh?
Okay, yes, Farah, please.
Emission tu kalau dia produce bila atoms release energy, kalau excitation dia produce bila atoms absorb energy.
Alright, as energy, and then it's going to move to the excited state. Okay, it's good, Farah. Thank you. And then when they release energy, but release energy not necessarily is going to produce emission. Okay, release energy can be into two types. Okay, they will release dalam bentuk haba. Okay, they can release in the form of heat. Kalau dia dalam bentuk heat tu, and then you can feel the heat tu lah dekat bekas tu kan. Okay, dekat the container tu you can feel that the temperature is like increasing. Okay, but we prefer the second option whereby the emission, the energy will be released in the form of fluorescence, okay, or emissions, okay, because we want to measure the intensity and that intensity actually giving information, okay, about the concentration of your analyte. Okay, it's good. Okay, may I have maybe another one? Okay, anybody who would like to volunteer? Zahin, ni budak handsome. Muhammad Zahin. Muhammad Zahin, are you there?
Hello.
Alright, okay, Zahin. Itu
Ya,
ayah
ya saya.
eksperimen tu. Alright. So what's the thing that you can share with your colleagues? Okay, something that you learn. Mestilah kita duduk kat masjid ilmu, mestilah dapat ilmu, takkan tak dapat. Kan you duduk dekat masjid contohnya dengar apa ni ustaz bercerita 2 jam kan, takkan tak dapat apa-apa. Balik tu tahu apa belajar dekat ustaz ni. Entah. Kau tak kena, samalah you buat eksperimen tu, actually you spend 2 hours 3 hours. Actually you are learning something new. Okay, so tu majlis ilmu juga tu. Because depending on our intention. Kalau you intention tu tak betul, you lupalah semua. Okay. So Zahin, something that you can share. Come on, dengan ayah anda.
Okey. Sebenarnya kami punya eksperimen tak jadi sebenarnya sebab
Apa cerita kenapa tak jadi and then bagi reason. Okay.
Okey. Dia mulanya sebab larutan quinine tu patutnya Cik Izwan yang kena settlekan, tapi masa tu Cik Izwan tak ada. Jadi kami kena settlekan stock solution tu.
Okay.
Lepas tu dah buat, lepas tu tersalah. Result kita orang dapat lain. Pada asalnya wavelength emission wavelength around 500, tapi kami dapat 700.
You guna quinine ke guna benda lain?
Guna quinine.
Kalau anak dia guna quinine, kalau anak dia salah pun prepare, okay, katakan instead of prepare 0.1 molar, anak dia prepare 0.3 molar. The wavelength is going to appear at the same wavelength. Okay, so regardless concentration apa, dia akan appear the same wavelength. Jadi kalau daripada 500 dia jadi 700, benda lain tu.
Mungkin lah sebab masa nak prepare tu, concentration acid tu dia macam kita orang confuse sikit dengan Cik Raja.
Ada baca-baca tak masa run tu? Sebab tempat tu keras sikit tu.
Oh, yang run tu kami just prepare je. Yang run tu kami tak ada time dekat basin tu. Cik Izwan yang settlekan sendiri sebab Cik Raja kata Cik Izwan pagi tu tak ada.
Mungkin ada benda halus, makhluk halus dalam tu. Sebab tu dia lari sikit. Ayah dia gurau je. Okay, dia because actually even though as long as you are using the same material, okay, the same chemical, it's going to appear at the same wavelength. Okay, so maybe there might be some contamination, or maybe you are using a different material, or maybe you put some other thing lah, mungkin acid ke apa, tak tahu lah. Okay, tapi apa yang you faham fluorescent ni anak dia?
Okay, apa yang saya faham, fluorescent ni sebenarnya dia menghasilkan cahaya. Semua bahan yang akan menghasilkan cahaya, masuk fluorescent tu sendiri menghasilkan cahaya kan. So macam mana dia hasilkan cahaya? Dia bercahaya bukan dalam visible macam kita nampak, contoh dia dalam keadaan UV. Contohnya quinine kita tengok tak nampak, tapi kalau kita exposekan dekat dalam UV, kita akan nampak warna dia, warna hijau rasanya.
Biru.
So biru. Okay. So dia ada faktor-faktor dia lah. Contoh dalam eksperimen tu kita nak tengok.
Anak anda sebut bahawa fluorescent ni adalah something yang menghasilkan cahaya.
Ya, saya. Ya, betul.
Kalau handphone? Dia boleh hasilkan cahaya juga tu. Adakah handphone? Tak ada nak usik Zahin. Okay.
Dia punya teori dia fluorescent, dia menghasilkan cahaya selepas dia excite, lepas tu dia pergi ke relax ground.
Dia punya term tu macam Pak sebut tadi tu, dia hasilkan cahaya selepas proses emission, excitation. Dia excite and then dia tak stabil, okay, and then dia akan emit. Okay. Right, anak. So I think okay, thank you Zahin. Yang penting actually ayah dia nak nampak you berani dan bercakap je. Salah tu tak apa, okey je. Pembelajaran macam tu lah. Okay, so in fact ayah dia lebih suka yang tidak formal begini, dan kalau tak faham tanya. Okay, sebab otherwise ilmu tu tak masuk. Pertama bila datang ke majlis ilmu ni majlis ilmu, kuliah ni majlis ilmu tau. Jangan kau majlis ilmu tu belajar pasal Quran Sunnah je. Belajar kimia tu pun juga adalah majlis ilmu. Okay, attitude kita kena betul. Okay, ya Allah, aku masuk majlis ilmu ni kerana kau ya Allah. Sebab kimia ni pun adalah ilmu kau juga. Dengan kimia ni pun aku boleh dekat kepadamu ya Allah. Macam tu. Okay, so hari ni cakap ayahanda saya nak mengajar pasal fluorescence. Bagi saya faham fluorescence ni apa, ya Allah. Okay, mudah-mudahan dengan fluorescence ni saya lebih dekat lagi untuk memahami sunnatullahmu, ya Allah. Macam tu. Ya, nak ada. So nampak tadi macam okay, adalah you understand here and there, boleh faham, okay, because you terus terjun kepada amali. Maybe ilmunya tak berapa sangat kan. Orang amal ni biasa kalau ilmu tak ada dia macam sesat lah kan. Kan, jadi ada ilmu dulu barulah kita amal. Patutnya sebaiknya kita ada ilmu, belajar dulu barulah kita buat eksperimen tu. Okay, itu yang sebaiknya. Maknanya kita ada ilmu baru kita amal. Bila kita amal tu baru cakap ilmu. Tapi tak apalah, okey je. Tak masalah. Sebab dia pembelajaran tu dia boleh dua hala. Okey, anak dia. Hari ni actually ayahanda ada share 5 slide. Ayahanda dah pecah-pecah sebenarnya slide apa untuk notes tu. Dah pecah-pecah pendek-pendek. Okay? So prepare 5, ada 5 slide. So hari ni akan go through, tak tahu 2 ke 3. Tapi ada a few videos. Jadi hopefully bila go through tu, okay, suppose you tak ada, cuba catat. Kalau tak faham, tanya dengan ayahanda. Okay? Alright? And now I'm going to start, with the first slide. Okay, basically, which on the introduction. Apa pula ni? Okay, sekejap ya, sekejap. Okay, introduction. I think you're familiar with this, anak dah. Okay, I mean the spectrum. And I think when we discuss about the UV visible spectroscopy, when we discuss about UV visible spectroscopy, okay, the topic that already passed, okay, that we already, we just finished discussing about this. Actually, we are talking, okay, the EMR, the electromagnetic radiation. Okay, ini EMR bawah ni, ini semua EMR ni. Okay, we mean from cosmic ray, gamma ray, X-ray, and so on. But in the UV visible spectroscopy, we are dealing with ultraviolet and visible and also infrared lah in a way. Tapi actually what we focusing is ultraviolet and visible. But certain instrument they will cover both. Okay, tiga-tiga region ini. And similarly in fluorescence, okay, we also going to work still in the same region. Okay, kalau UV visible spectroscopy, actually we work in the UV and visible seperti nama dia. In fluorescence, okay, we are still working in the same region as well. Okay, UV and visible. Alright. So makna excitation tu kebanyakan akan guna UV lah. Okay, because UV ni dia punya tenaga lebih tinggi, okay, berbanding, okay, compared to visible. Alright. Okay, anak dah. Something very interesting. Ini yang Allah dah cipta, okay, dekat alam kita. That's why if you know, if you appreciate, okay, ilmu ni kita orang sains ni. Ilmu sains ni actually banyak dekat apa ni Allah apaikan dekat environment. Okay, jadi kalau kita belajar ni, kita mungkin better off, okay, compared to ustaz yang mungkin tidak ada ilmu kimia berkaitan dengan fluorescence ini. Okay, so we have and then we know kenapa binatang ni kadang dia ada fluorescence. Ni kelip-kelip mana ada, firefly. Dia ada cahaya macam ni, tugasnya untuk apa yang Allah create, okay, dengan cahaya ini. Okay, apa dia punya fungsinya. Jadi kita kata bila kita tengok tu, subhanallah, kita pun memuji Allah SWT because it's the greatness, something that we cannot imagine before. Okay, this actually the orang panggil kunang pun ya, firefly, Jadi basically, the purpose of having, this slide ni basically for apa ni, untuk dia panggil mates dia lah, okay, untuk tujuan pembiakan and so on. And apart from that, if you go to deep sea, okay, we'll see that some of the colony or bacteria, okay, they also fluoresce, okay, and even some apa ni macam obor-obor, okay, they also fluoresce. Okay? So subhanallah, this is all the fluorescent phenomena, okay, that occur, in the environment, in the deep sea, and many others. In fact, some fern, okay, pakis also fluoresce. Okay? Right. This is something that maybe you can see, if you go, at night, to fun fair, okay, for instance, you see a lot of, this kind of light. Okay? This is a fluorescent material, okay, that been put inside here, and then, once the material absorb, the light from the surrounding, okay, particularly from the UV region, it's going to emit the colors, okay. That's going to emit the colors. That color actually fluorescent light. So you can see from here, actually, the colors is very, very beautiful. And this, if you take, this specimen and you run by using UV visible, by using fluorescence spectroscopy, okay, you will see very nice peak, okay, that been generated, okay, from this. Okay, so fluorescence actually, the term, one of the term, okay, that been used, to explain this phenomena lah. Okay, but fluorescence actually just one of the bigger terminology that they use, okay, which is luminescence, okay, luminescence. Jadi luminescence ni can be a phosphorescence, okay, can be fluorescent, and we have many others. Among others, macam kita lihat kat sini ni adalah contoh chemiluminescence, okay. Chemiluminescence adalah adalah fluorescence yang terhasil akibat daripada tindak balas kimia. So chemiluminescence. Luminescence ni maknanya mengeluarkan cahaya lah. Mana bahan ni mengeluarkan cahaya, okay, because of the reaction, okay, chemical reaction that occur. Okay. So chemiluminescence refers to the emission of light with limited emission of heat as a result of chemical reaction. Okay, dia specify limited emission of heat sebab kalau heat ni banyak sangat di-emit, so light ni akan tak ada lah, okay, because dalam fluorescence, dalam chemiluminescence, okay, we need the light, the heat, okay, to be as small as possible, okay. So we want most of the energy to be emitted in the form of emission. And here another in the marine life, okay, you can find even more, the obor-obor, there's so many things inside, this is a small fluorescence, okay. Ini ada fungsi-fungsi dia dalam kehidupan, okay, untuk dia panggil mates dia, untuk dia basically, untuk dia dipanggil pemangsa dia untuk makanan dia and so on. Okay, bila cantik macam ni, attractive, so there will be other creatures, okay, who like to approach. Okay, once they approach and then dia akan kena ngap lah. Alright. Okay, and this is something else, okay, that we see. Ini memang sangat cantik lah sebenarnya. Jadi from this alone, if you creative, you can create a project. Okay, create a project to promote or maybe to show them, okay, the fluorescence, how beautiful fluorescence is. Okay, and actually in the near future, okay, this was something, okay, they are thinking. Now if you go to some of the some of the areas, I don't know, but like in UKM, they have, one Furnarium ni actually is like, they call it Taman Paku Pakis. They have collection, quite significant collection of ferns, okay, fern of Paku Pakis, and some of them actually is fluorescent. So when you show, the UV light, okay, so the what you call it, the leaf, okay, it's become like this, very colorful, which is very nice. And maple trees is the example of the tree, okay, that can fluoresce, and many others here, okay. And these two actually, just the ornamental lampu hiasan dekat tepi jalan, okay. But what I'm trying to say, in the near future, actually we are thinking of, we're having tree, okay, we're having tree here, and we're having also street light. So in the future, maybe, with the advancement in science and technology, okay, we might be able, okay, to combine these two. I don't know, my cursor ni dia macam liar sikit, okay. Right? Maybe you can combine the tree and also the what you call it, the light together to produce, tree, okay, that can emit lights, okay. So this could be, the street light, okay, in the near future, and that's possible. All right. Okay, and some history, okay, how fluorescence has been, what you call it, discovered. Actually, just simply because of, the quinine, social quinine, has been put, in the church. This according to this report, okay, and then suddenly, the sunlight, okay, passing through the window here and hit, the clean solution, and then the solution appeared to be blue in color. Okay, this guy here, okay, when they look, at this solution, the color changed, okay, to become blue, okay, become blue. So something that, he just wonder, and with a little bit of research. And then actually they know, how this happened, okay, because of the quinine basically is going to absorb, the light, the UV from the sun, and then the molecule become excited and then releasing, okay, and emitting, okay, the the secondary light, okay, which is called fluorescent, which is blue in color. Okay, so now actually you know the phenomenon why this happened. So exactly your experiment actually is about this. Okay, you are repeating experiment that has been conducted long time ago, in 1845. It's not really proper setup, but actually it's happened by incident. All right. So so what happened, quinine, if you look at the right angle here, 180, you appear transparent. Okay, but if you measure at 90 degree, okay, like what we happen in fluorescent is appear blue, okay, in your eyes. Okay, and this actually because of you are observing the fluorescent light of quinine. And this actually the spectrum. So Sahin, this is supposed to be the spectrum yang you dapat lah. Okay, this is supposed to be spectrum that you're going to get in your experiment. So this actually the red one actually the excitation spectrum. Okay, so the yellow one actually the emission spectrum. So excitation spectrum or the absorption spectrum. Okay, I mean in UV visible spectroscopy, okay, the spectrum actually is called absorption. Okay, but in fluorescent we call it absorption. So this is the absorption and this is the emission. The emission sometimes, okay, I mean we also refer this as the fluorescent. So absorption, emission, or excitation, emission, or absorption, fluorescent. Okay, so different terminology that we use. So you can see from here, actually, the two spectrum is like mirror image, isn't it? If you put, an axis here, for instance, okay, you will see that, these two more or less is like mirror image, if you ignore, the bump here, all right? And then, the difference between the two, okay, difference between the two peaks actually is called a Stokes shift. I don't want to go much detail, on the the technical part. Later on, you can see in the video. Okay, so why luminescence? Luminescence actually the general term, okay, that including phosphorescent and fluorescent. So luminescence actually the emission of light, and if the emission actually involving the same what you call it the same there is no flip in the electrons, so we call it fluorescent. If there is a flip in the fluorescent, in the electron, we call it phosphorescence. All right, and if it involves some what you call it chemical reaction, we call it chemiluminescence. If it involves the use of radio frequency, we call it radio luminescence. Okay, so there's different term. Okay, we will go into that later on. Okay, the advantage of luminescence or the advantage of fluorescence, okay, basically it's very sensitive. Why sensitive? Okay, because of when we're doing the measurement, we are measuring, at 90 degree here. Okay, when we do the measurement, actually we are measuring at 90 degree. Okay, 90 degree ni maknanya daripada sini ke sini 90 degree. But in UV visible spectroscopy, we are measuring at 180 degree, right? So by doing our measurement here, we are avoiding any what you call it stray light, okay, that's going to occur at 180 degree. So we're doing the measurement at 90 degree in fluorescent, okay, because by doing so we can avoid the stray light, okay, that will be detected if we measure at 180 degree. That's why the measurement become very sensitive, because the background signal actually is much less. Okay. Very selective. So these are the two criteria of fluorescent. Satu, very sensitive. Why sensitive? Okay, because less background signal. Why less background signal? Because we measure at 90 degree. All right. And then secondly, it's very selective. Why selective? Because not many molecules can fluoresce. Okay. So if too many molecules can fluoresce, so every molecule that we determine is going to form their own fluorescent light. If that happens, and then we will encounter situation whereby too many signals to be measured. Okay, so itu akan memberikan disturbance or interferences. So it's selective, okay, because not many molecules can fluoresce. So this is actually very important features, you know, of fluorescent method. Some of these disadvantages, okay, because it's not a universal, okay, meaning when you buy the instrument, actually it's quite expensive, maybe 200K for instance, but you can only use the instrument for molecule that can fluoresce. You know, maknanya dia tak universal, okay. Of course, if possible, you want to buy only one instrument, and then that one instrument can be used for any other measurement, okay. But that's not the case lah, yeah. Okay, and then require more expertise. Okay, so normally, you know, you need somebody macam Zahin tadi, bila Encik Izzuan tak ada, habislah dia kena prepare sendiri dan habis pun tak jadi. Okay, jadi dia need some expert lah, okay, basically, okay, who understand, you know, some you know, the background of the instrument and so on. Okay, for us to use this method. And then a relative technique, okay, because we are not going, you know, the absolute method. Okay? So if you are using different spectrophotometer, different instrument, so the result will vary, okay, slightly. All right. So limitation one, not universal. Why not universal? Because not many molecule will fluoresce. Second, okay, we need expertise. We need somebody with some technical knowledge, okay, to run. And thirdly, because of it's based on the relative technique, not absolute. And type of illumination anak-anak, ini yang Iris sebut tadi, we have photoluminescence. Photoluminescence ni because luminescence terhasil kerana kita memberikan cahaya kepada molekul. Molekul menyerap cahaya, menyerap foton dan menghasilkan fluorescent ataupun phosphorescence. Okay, fluorescent ni because tidak ada, because of, you know, the electron still singlet in a singlet state. Phosphorescent because the electron actually in a triplet state. I want to explain what is single, what is triplet. So by now, hopefully, you should be able to know that. Chemiluminescent, okay, because the luminescence has been produced, okay, due to the chemical reaction that occur. Bioluminescent ni macam dekat kunang-kunang tadi, okay, I mean the luminescence has been produced because of some biological reaction that occur, you know, maybe within, you know, the firefly, and then, you know, within the starfish, okay, or the obor and so on. Electroluminescence, okay, when we apply electricity, okay, to some system, and then it start, you know, producing the luminescence. Radioluminescence, okay, because we applying radio frequency ray, okay, ray in the radio frequency wavelength. Okay, once this been absorbed, it's going to produce the radioluminescence. But in our experiment, no, sorry, in our subject, okay, for this course, okay, we're only going to discuss the fluorescence, so very small part of it. So in fact, you know, I mean, this is also showing, you know, when you talk about fluorescence alone, it's cover actually it's bigger areas. Okay, but what we're going to study, what we're going to focus is on the fluorescent only. That show, you know, that the ilmu Allah ni sangat luas lah. Okay, so no matter what, okay, so what we learn actually just a small portion of it, and hopefully by having some knowledge on that, we will appreciate more, okay, what Allah has been giving to us. Okay, molecule that fluoresce. Macam mana? How can we know whether that molecule is going to fluoresce or not? Okay, maybe I start for a while, okay. Takut anak dia tidur ni. Okay, what makes fluorescent fluoresce? To your understanding, how we know, okay, whether that molecule is going to fluoresce or not? What sort of hint, okay, that we have? Muhammad Danish Irfan, are you there? Or anybody who want to try? Okay? Muhammad Danish, are you there? Yes, Danish. Apa menyebabkan molekul tu dia boleh fluoresce? Okay, once you are given, you know, like quinine. Okay, you got the quinine structure. How you know that quinine is going to fluoresce? And supposedly Ayandi gives you water. And how you know whether water ni fluoresce or not? Anything that we can more or less, any clue? Okay. Wah, kena kejap tu. Okay, boleh cari. Okay, maybe anybody want to try? One Nur Afrika. As I said, you ni kena berani ni anak dia, kena bercakap salah pun tak apa. Okay, because we are learning. Okay, this is a platform whereby okay, you need to learn. Okay, and once you graduated already from USIM, you are different. You are different. That's different story. I mean, you are different person already. Okay, because people will refer at you. Muhammad Faris Naufal, jarang nampak you all ni dalam lab. Ahli lain ke? Muhammad Faris Naufal, are you there?
Yes, Doktor.
Alright, okay. Muhammad Faris. Yes, please answer me.
I also still nak cari lagi Doktor jawapan ni.
Kita check kat mana tu? Faris.
Nanti tengok balik slide.
Okay, try. Okay, come. Okay, any volunteers? Tak, macam mana dia boleh fluoresce? Okay, macam UV tu, macam ni nak tahu molekul tu boleh menyerap UV ataupun tidak? Any volunteer?
Kena tengok dia punya structure.
Okay, betul. Tengok structure. Lepas tu, dah tengok structure dah. And then, apa yang kita boleh kata dia fluoresce atau tak fluoresce?
Kalau macam quinine, dia aromatic. So, kalau nak bandingkan dengan H2O, H2O dia punya structure just macam tak ada aromatic pun. So, that's the difference.
Apa yang menyebabkan yang aromatic tu dia fluoresce? Mana pandangan anak anda ni aromatic dia fluoresce lah, betul tak? Air tu tak fluoresce. Jadi apa yang menyebabkan air tu tak fluoresce dan aromatic tu fluoresce? Because of dalam untuk dia fluoresce tu, kita mesti boleh excite dia dulu kan, betul tak? Because excitation tu can only happen, emission can only happen, or fluorescence can only happen if you manage to excite, the electron. If you cannot excite the electron, okay, so no way, okay, you can get the fluorescence. And then, okay, how can we excite the electron? By giving energy, isn't it? Okay, you giving energy will be absorbed. Okay. Okay, tapi sekarang ni, okay, suppose you have water, H2O, and then you have quinine, okay, dia ada aromatic, okay, aromatic. So, dua kalau you bagi cahaya, you bagi energy, dia akan serap, dua-dua dia akan serap. Okay. Dia akan serap, tapi air excited ke tak? Air tidak akan excited, okay, because air dia perlukan tenaga yang lebih tinggi, okay, untuk dia for the electron in water to be excited compared to quinine. Okay, quinine actually is going to use only a small amount of energy in order for us to excite them. Okay, the idea, the question is, I'm guiding you, Ananda. The idea is, apa yang menyebabkan satu molekul tu boleh mudah untuk menyerap satu molekul tu diperlukan tenaga rendah untuk dia excite, satu molekul tu dia memerlukan energi yang tinggi pula untuk excite. Air perlukan tenaga tinggi untuk dia to be excited. Okay. UV alone mungkin tak cukup. Okay, sebab we are talking about the UV and visible region kan. Okay, so air maybe tak cukup untuk kita nak excite dia. Okay, tapi untuk quinine okay. Kan? Jadi apa menyebabkan quinine tu boleh menyerap tenaga sikit untuk dia excite? Anybody okay already there, dah dapat hidayah dah untuk jawab based on ayah dia punya hint ni. Ahmad Faik, ini nampak gambar kat centipede ni. Si orang kuat ni selalu banyak bukit ni, banyak gunung. Okay, Faik, any clue? Ada. Macam mana you nak tahu apa ni tenaga tu banyak, tenaga tu rendah untuk satu elektron tu di-excite? You nak tahu macam mana? Apa yang menyebabkan satu elektron boleh kita excite? Mesti dia kena keluar habis ini. Kita mesti kena tendang dia. Kan, betul tak? Jadi apa yang menyebabkan, apa faktor yang boleh menyebabkan dia cepat untuk keluar? Ini basic sangat, ini akidah. Ini adalah akidah kimia untuk acceptation ni. Ayah anda kalau anak tak faham yang ni, mana susah kan nak faham bahan ni kan? Banyak lagi bahan ni. Anak anda, anything? Tak apa yang menyebabkan sesuatu molekul itu boleh mudah untuk elektron itu keluar. Dan apa yang menyebabkan semua molekul sukar untuk dia keluar. Dia punya bonding ni macam mana? Anak tak jawab air minum kopi lah nampaknya ni. Tak respon. So how you going to relate that with the what you call the bonding, okay, that we have, okay, in apa ni, in molecule. What sort of bonding that we have? Apa jenis bonding yang kita ada?
Double bond.
Okay, double bond. Lagi? Macam air ada double bond tak anda?
Tak ada.
Air tak ada double bond. Kalau quinine ada double bond.
Ada.
That could be the reason. Double bond. Okay, lepas tu macam dekat apa ni, dekat quinine tu, double bond tu macam mana? Adakah dia alternate ke atau macam mana? Dia ring kan? Benzin kan? Dia benzin kan? Okay. Dia alternate ke macam mana?
Dia alternate.
Dia alternate kan? Dia single, double, and that's called conjugation, conjugate. Right. Double bond, elektron dalam double bond dengan elektron dalam single bond. Mana yang mudah untuk kita nak keluarkan dia?
Single bond.
Single bond lebih mudah untuk kita keluarkan. Sebab? Single bond tu nama dia ikatan apa? Kan ikatan tunggal tu ikatan apa? Ikatan covalent ke? Ikatan pi ke? Anak dia? Jangan Dennis saja, semualah bagi. You ada ramai ni. Ada 27, 8, 9, 30, 36 orang ni. Tak, ini basic dan ada ni. Ikatan ada berapa jenis? Okay, kita ada ikatan pi, ada ikatan apa lagi?
Sigma.
Ikatan sigma tu ikatan single tu lah, ikatan sigma tu. Mana strong ikatan sigma dengan ikatan pi, anak dia?
Pi.
Pi lebih strong.
InsyaAllah.
Masya-Allah. Comel. Okay. Kenapa you kata ikatan double bond tu lebih strong? Pernah dengar tak apa ni resonance? Dia belajar masa sekolah rendah dulu kan, sekolah menengah kan, resonance. Electron resonance. Yang dia menstabilkan dia punya structure. Kan? Macam electron resonance ni berlaku dekat air, dia berlaku ke tak? Tak, okey, betul. Dekat quinine dia berlaku ke tak? Berlaku. Jadi dalam elektron resonan tu, elektron tu bergerak ke tak sebenarnya?
Bergerak.
Dia bergerak. Okay, dalam resonan, okay, bila kita ada single bond, double bond, okay, actually dia alternate macam tu, dia akan ada kesan resonan. Resonan tu elektron bergerak, sebab tu dia punya double bond tu boleh bertukar-tukar. Mula-mula yang single tu jadi single, lepas tu bila resonan yang single tu jadi double bond, kan kita tengok structure dia kan? Ini akhirnya tak explain berguna basic sangat. Okay? Jadi maknanya kalau kita tengok antara yang single bond, okay, dengan double bond ni yang dia tengok dalam konteks resonan tadilah, okay, dalam konteks conjugate. Sebab macam tadi dalam quinine kan dia ada dia ada ring. Jadi dia punya ring tu actually dia ada conjugation kan, dia ada conjugation. Kan? Bila ada conjugation, elektron tu akan bergerak, okay, di kalangan yang conjugation tadi. Bila elektron bergerak ni anak anda, lebih mudah untuk kita campakkan dia keluar, lebih mudah untuk kita colik ke ataupun kurang susah untuk kita colik?
Mudah dicolik.
Mudah dicolik kan, mudah dicolik, pandai. Sebab macam anak kita lah kalau dia main bersepah dekat kampung tu kan, kompres satu orang anak yang diletak dalam bilik dia kunci contohnya kan. Dia pegang, mak ayah dia pegang dulu tangan macam tu kan. Yang anak esok lagi ni kat luar ramai-ramai dengan anak-anak kampung semua main kat luar. Mana mudah dicolik? Mestilah yang kat luar tu mudah dicolik sebab dia tidak diikat kat mana-mana. Tapi elektron yang dalam sigma tadi, dia diikat kiri kanan, dia tak boleh gerak kan, dia tak boleh gerak. Sebab tu bila kita nak keluarkan elektron daripada sigma bond yang ada sangat sukar, kita perlukan tenaga yang sangat tinggi. You kena tumbuk mak ayah dia, tumbuk bersilatkan mak ayah dia dah pengsan baru dia boleh keluar budak tu. Kan? Tapi kalau budak tu tengah main dekat luar dengan ramai budak tu, parents tengok daripada jauh saja, dia pun tak perasan anak dia hilang. Dan kita pun tak perlu bertumbuk, kita semua perlukan trik aja. Bagi tenaga sikit, bagi gula sikit, ada keluar dah. So analogi macam tu lah. Minta maaf kalau analogi tak kena, tapi actually untuk kita faham. Jadi bila dia resonan tu, dia lebih mudah. Sebab tu, kita nak tahu sama ada molekul tu boleh diabsorb energi ataupun tidak dalam UV region dan dalam visible region ni, tengok. Dia ada tak functional group gas? So ni, dia ada tak resonan? Kesan conjugation dia ada tak? Kalau dia ada conjugation, maknanya adalah double bond, single bond, double bond, single bond, alternate macam tu, itu maknanya conjugation. Kalau ada tu insya-Allah, dia akan boleh menyerap. Satu lagi kita akan tengok dia punya planarity, dia planar. Jadi kalau dia memang benzene ring tu, dia planar lah tu, dia tak boleh nak gerak sangat. Dan kalau katakan dia macam anthracene sampai 3 benzene ring tu rapat macam tu, dia tak boleh bergerak. Sebab kalau dia bergerak, kalau molekul tu boleh bergerak banyak sangat, contoh kalau dia banyak single bond, nanti semasa excitation, pergerakan tu masih berlaku juga. Bila pergerakan tu berlaku, energi tu akan dibuang. Energi masa excitation tu akan dibuang ke environment. Sebab tu kita nakkan molekul tu kalau dalam fluorescence mesti molekul yang rigid dan mesti mengandungi banyak conjugation macam tu. Jadi akhirnya terus pagi ni dah habis 1 jam dah. Alright, pergi balik tadi tu, kita anda tak faham. Jadi ini, jadi untuk molekul to fluoresce, untuk supaya so that for the molecule to fluoresce, it should contain lots of conjugated pi electron. Masih mesti ada pi electron. Dekat tadi lah, dekat ikatan pi tadi tu. And dia ada multiple ring structure. And then dia coplanar. Bin dia rigid. Example ni lah, macam fluorescein, anthracene, porphin. Nanti balik anak anda cuba Google nama-nama ni. Dalam ni dan tengok structure macam mana. Semua structure dia adalah yang ada banyak conjugation ni. And also it's a planar. Planarity lah, mana dia less energy loss. This is another example. Example of fluorescent molecule. So fluorescein isothiocyanate. Jadi kalau you lihat ni, a lot of conjugation, isn't it? Double bond, single bond, double bond. Ini semua conjugation. Ini adalah semua conjugation this area. Dia pun conjugation. Dia also conjugation. So that's why actually it's very easy for us, to excite electron, from this molecule. Because of the electron, the pi electron is going to move, around the molecule. Alright. So ini ada another example, erythrocene, the reactive lah. So ini juga dia akan fluoresce. If you look at this, so dia akan fluoresce. So what happened? Masa fluorescent, so we having this. So once you're giving a photon, the energy, the photon will be absorbed, and then this electron is going to be, it's going to move to the higher level, to the next level of energy, of the energy level. So if this is the excited state, singlets, and this is ground state, singlet. So once you give photon, you can see the blue line here. The blue line is going to move from ground state. From ground state to excited state. And then because of some movement in the molecule, the molecule is going to move, and some of the energy will be released into the surrounding as a heat. So kalau dia, if the garis tu macam goyang-goyang macam ni kan, macam dia keluk-keluk ni, ini menunjukkan ini bukan emission, ini adalah a heat. Okay, meaning the energy will be released as a heat. Okay? And then finally, the energy will be released in the form of fluorescence. They are going to emit the fluorescence. Okay, from singlet state, okay, from started state, okay, to ground state. Okay, anak dah. That's the first introduction, that you need to know. Okay. So ada pembahas di pecah-pecahkan ni, supaya dia boleh follow mudah. Any question anak anda up to now? As I said, it's good for you to ask me if you don't understand. Okay, better then you ask somebody else, bila you dah kerja nanti. Nanti dia gelak je dekat you. Ni brother sini soal akidah kimia pun tak settle. Macam tu. Okay, anak anda? Any questions? You can follow very well. Nur Adila, are you there? Can you follow? Nur Adila, siapa? Nur Adila, Muhammad Zulkifli.
Doktor.
Yep, yes. Siapa ni?
Oh. Tadi mic saya rosak. Boleh follow.
Boleh follow. Apa yang you follow, Adila?
Apa yang saya follow hari ni?
Apa yang you dapat
belajar
daripada ayah dia punya nota tadi?
type of molecules that fluorescent,
Okay.
type of luminescent,
Apa dia? Okay, type of luminescence ada berapa?
ada
Contoh type luminescence.
photoluminescent, radioluminescent, lepas tu lagi
Okey, tak apa. Apa beza photoluminescence dengan radioluminescence? Apa beza dia?
dia punya
Radioluminescence dengan photoluminescence.
yang part tu saya tak berapa faham sangat.
Oh, macam mana? Tadi kata boleh follow.
Okay,
Okay.
sekejap.
Cuba test Fatihah pula. Ni Nur Fatihah ni, saya tak akan baca Fatihah ni insya-Allah ni. Fatihah, are you there? Nur Fatihah binti Rahman. Nur Fatihah, are you there?
Yes.
Okay, Fatihah. Okay, what you get, from my first lecture or the introduction?
Firstly, I know the different types of luminescence.
Mm-hmm.
Then
Apa beza? So, apa beza antara photoluminescence dengan radioluminescence?
radioluminescence is use radio frequency rate.
Mm-hmm.
And
To
for
produce. Okay. They use radio frequency range to produce what?
to produce
Luminescence. To produce emission. Alright. Okay.
to produce emission.
How about the photoluminescence?
Photoluminescence about photon.
Photon tu apa? What is photon ada? Photon ni adik-adik ingat dengan proton ke?
Oh, gitu.
Photon dengan proton ada kena mengena ke?
No.
Tak ada. Okay. So photon tu apa?
Photon light.
Light. Okay. Okay. Full stop. Okay. Alright. It's good. Now, I'm going to show you videos. Okay. So time for you to relax, but not too relax. Okay. I want you to follow, the videos. The videos actually simplify. Okay. Because you can see the movement of the animation and so on. So you're going to simplify. Actually, I intend to show 4 videos today, but I don't know whether I have the time. Sekejap. Tak apa, dia kata lagi lambat, lagi selamat. Walaupun mungkin tak progressing, not very well, but as long as you can follow, I think that's good enough. Okay, 1, 2, 3, 4. Actually, I share with you 7. Okay, 7 videos altogether. Okay, so hopefully, okay, please during your spare time, or you need to allocate some time for you to go through into it. So I want to go to the basic principle of fluorescence dulu, ya. Just to one, okay. So please have a look, try to focus, okay, and then we discuss afterwards. Yeah.
Welcome viewers to yet another video on analytical instrumentation. In the current video, we will be going through the basics of fluorescence and phosphorescence. So before starting with the basics, let us understand some terms. We all know that the electrons present in the atom have a specific spin associated with them. These electrons pair themselves with electrons having spins opposite to theirs. As a result, the net spin of the pair of electrons is 0. When the electrons are paired with electrons having opposite spins, they are said to be in a singlet state. However, certain times arise when both the paired electrons have same spin associated with them. Such a state is called a triplet state. Looking at the energy level diagram, we can try to understand how phosphorescence and fluorescence are produced. The energy level diagram helps one understand the production of fluorescence or phosphorescence. As seen in the diagram, there are different energy states. In the ground state of molecules, the molecular energies are constant and possess minimum value. When external radiations or EMR fall on the molecule, it absorbs the energy from external EMR. Due to this absorption, an electronic transition takes place, and molecules transition to higher electronic states, like second electronic singlet state or first electronic singlet state, as depicted in the diagram. It should be noted that electronic transitions will occur only for specific molecules and only when bombarded with specific wavelengths of EMR. This is because only radiation of a specific wavelength and energy is absorbed by a characteristic structure. As seen in the diagram, lambda 1 refers to the wavelength of light absorbed by the molecules to transition to first electronic singlet state. The excited singlet state remains for certain time, its order being 10 to the power minus 8 to 10 to the power minus 4 seconds. After this short time interval, the electrons return back to the ground singlet state. During this transition, energy is released in the form of emissions. This phenomenon is called fluorescence. This transition involves less energy than the original absorption. So, the emitted wavelength is greater than the absorption wavelength. That is, lambda 3 is greater than lambda 1. One can perform both qualitative and quantitative analysis of a sample by studying and measuring its fluorescence. Sometimes, electrons, instead of transitioning from first electronic singlet state to ground state, go to first excited triplet state. They stay there for some time before transitioning to the ground singlet state. This transition is accompanied by emissions being released. This phenomena is called phosphorescence. Even phosphorescence helps one perform analysis of an analyte. Fluorescence is immediate emissions of absorbed radiations, whereas phosphorescence is delayed release of absorbed EMR. Now let us try to understand the principle of fluorescence measurement. Again, we can refer to the diagram shown here. As seen, the detector is placed perpendicular to the light path of emitted source. The analyte is placed in the cuvette. These instruments are employed with multiple filters or monochromators. One filter is placed between light source and analyte. This filter helps to achieve a good monochromatic beam of a particular wavelength that will be absorbed by the analyte. The second filter is placed between the analyte and the detector. This filters out the phosphorescence radiations from the stray light, and only fluorescence is measured. That's it for the current video. Hope you have learned the basics about fluorescence and phosphorescence. In the next video, we will talk about the instrument that is used to measure fluorescence. That is...
Okay, Ananda. Basically, this video showing to you, I try to discuss, two things, on the principle. The first one actually on the Jablonski diagram, the what you call it, the energy diagram. Okay, the energy diagram, and second actually on the instrumentation. Maybe I just show a little bit, so that maybe we can. Sekejap ya. Okay, this is the one. Okay, this is the one. Right. If you look here, okay, basically we having, these two electron, okay, in the beginning, and then once you're giving a photon, these two electrons going to, the electron is going to. I don't know whether you can see my cursor. Tak clear lah cursor ni. Okay, there are these two electron. Okay, once you give a photon, it's going to absorb, the energy, and it's going to excite. Okay, this actually they're going to go to the either first electronic singlet state, or maybe the second electronic, third electronic, and so on. Because we have so many possibilities. We have so many possibilities. So we assume the excitation actually, from S0, singlet 0 to singlet 1. Okay. So what happen after that? The molecule is going to be there here, for a while, less than a second. And then it's going to emit, emit the energy. Okay, it can go straight away, down, to the ground state again, and it's going to release, the light, and this actually is called fluorescence. Okay, that's the first options. A second option, basically, it can go into they're going to undergo the intersystem crossing. Why they call it intersystem crossing? Because here we're talking about the singlet. Dalam singlet ni, the two electrons actually having different spin. But triplet, the two electrons having the same spin. Singlet, different spin. Triplet, the same spin. Okay, like being explained in the video just now. So it's going to do the intercrossing, meaning it's going to cross from singlet S1 to triplet, to T1. Okay, so this can only happen if we want fluorescence to occur. Okay, fluorescence is going to involve the intersystem crossing. For fluorescence, we don't have, to undergo this intersystem crossing. So similarly, from here. Okay, so the energy will be emitted, whatever the remaining energy will be emitted in the form of phosphorescence. Okay, that's one. Any question that you want to ask another from here? Okay, from this diagram, any question that you want to ask? Okay, if you don't have any question, if I ask you, you're supposed to be able to answer. Okay, so I give you a chance. Any question that you want to ask me regarding, the energy diagram just now? Any question they want to ask? Kalau tak ada, dia tanya. Dia satu question yang tanya ni.
Betul.
Okey, okey.
Nak tanya boleh?
Boleh.
Kiranya yang diagram tadi, yang dekat electronic transition tadi, transition state tu kan. Bila dia anak panah ke atas ni, dia emit energy lah maksudnya. Bila dia ke bawah, dia akan jadi excited. Macam tu ke?
No, naik atas ni absorb. Dia akan naik ke atas ni excitation. Dia excite. Macam kita lah, bila kita excited, kita akan rasa teruja dan kita akan melompat contohnya lah kan. Jadi anak panah yang ke atas ni, anak panah yang di ke atas ni, ini menunjukkan excitation. Anak panah yang ke bawah ni, anak panah ke bawah ni, daripada excited state kepada ground state ini menunjukkan emission. Ni emission. Faham? Okay. Itu ke soalannya, anak dia?
Tu je doktor. Terima kasih doktor.
Okay, any more question? Any more questions? Okay, kalau tak ayah dia tanya satu soalan, ini kena jawab. Yang dah tanya tadi akan dikecualikan daripada menjawab soalan. Okay. Between fluorescence and phosphorescence, between fluorescence and phosphorescence, which one actually having high energy? Fluorescence dengan phosphorescence, mana yang ada high energy? Which one actually having high energy? Siapa yang nak tanya ni? Ada volunteer tak yang akan jadi penyelamat? Kalau tak, ayah dia akan panggil nama orang ni. Kalau tak ada, ayah dia panggil Afiq, Muhammad Afiq. Afiq? Oh, gambar kawan gambar tu. Ada kawan belakang ke Afiq? Pada dua Afiq ke?
Ada dua Afiq Doktor.
Pada dua Afiq. Ini nak Muhammad Afiq Muhammad Nur Azam. Oh, okey, Muhammad Afiq Muhammad Nur Azam. Yes, anak anda. Mana yang besar tenaganya? Okey, fluorescent ke ataupun phosphorescence?
Sepatutnya mengikut pemahaman saya fluorescent lah.
Pada pemahaman je, fluorescent mempunyai tenaga yang lebih tinggi daripada phosphorescent. Alright. Okey. Okey, betul. So nak minta Muhammad Afiq seorang lagi. Muhammad Afiq Daniel, are you there? Nama common Afiq. Okey, Muhammad Afiq Daniel. Tadi Muhammad Afiq, kawan ni seorang lagi tu, dia kata fluorescent tenaga lebih tinggi daripada phosphorescent. Which yang dia kata, dia tu, betul tu rasanya tu. Okey, betul tu. Jadi pada pandangan Afiq, okey, based on understanding, kenapa fluorescent dia tenaga lebih tinggi berbanding dengan tenaga untuk phosphorescence?
Kita tengok dia punya wavelength.
Okey, sebab wavelength. Okey.
Kalau wavelength tinggi, dia kiranya dia inversely proportional. Kalau energi tinggi, wavelength rendah.
Okey, betul. Jadi sekarang ni wavelength dia tinggi. Sebab wavelength tinggi. Kalau tengok ni, kita tengok rajah ni, wavelength dia sini. Ni lambda 4 ni. Jadi lambda 4 lebih besar daripada lambda 3. Betul?
Betul.
Betul lah kan. Sebab yang kekaran memanglah. Okey. Tak apa. Kita terima. Okey, betul jawapan tu. Okey. Tapi kenapa, okey, mungkin soalan seterusnya. Okey, kenapa fluorescent tu, kenapa phosphorescent appear pada panjang gelombang yang lebih tinggi? Macam tu. Alright. Kenapa phosphorescent appear pada panjang gelombang lebih tinggi? Ada cadangan tak pada siapa yang dia perlu tanya ni? Ada ke nak cadangkan pada siapa yang dia perlu tanya ni? Siapa ketua untuk ni? Yang dia lupa dah. Siapa kelas silap sini?
Saya Doktor.
Afiq. Okey, Afiq. Okey, Afiq. Afiq bagi apa ni? Bagi satu nama. Siapa yang ayah dia perlu tanya ni?
Izzati Doktor.
Izzati, are you there? Izzati ni top in the class kot kan? Afiq, dia best student tu ya?
Betul.
Ada ke Izzati ni? Izzati, are you there? Macam tak ada je nama ni.
Yes, Doktor.
Oh, ada. Okay, Izzati. Okay. Why phosphorescence Izzati? Just give a try, Izzati.
Ya, Doktor, sekejap
Dia bincang kat mana tak tahulah. Tak apalah, ayah dia minum kopi dulu lah. Okay, while waiting for Izzati, okay. Anybody who want to try? Mana Farah yang peramal tadi? Hilang dah. Farah, are you still there? Senyap dah. Farah, are you there? Ni tak ada ni kan ayah dia kata kursi tak datang ni. Farah 1, are you there? Farah Baharudin 2, are you still there?
Saya sedang mencari jawapan ayahanda.
Tak, okey. Tak apalah, ayah anda jawab lah ya. Ayah anda jawab.
Sebab
Okey, sebab apa?
sebab dia dekat triplet state. Saya try je, Doktor. Saya try
Tak apa, betul, okey je. Tapi buat cepat sebab apa? Okey, macam ni. Okey, anak anda. Okey, ini dekat sini ya. Ini absorption. Dengar ni baik-baik ya. Dengar baik-baik supaya you boleh sampai bila you boleh ingat ni dan you boleh explain dekat makcik, pakcik okey yang akan tanya ataupun pada adik-adik nanti ya. Okey, dekat sini okey daripada kedudukan ni okey elektron dia akan mengambil foton dan dia akan excited Okey, dia akan naik atas. Okay. Dekat atas ni, masa dia naik atas ni, ada sebahagian molekul ni dia bergetar tau. Dia bukannya senyap-senyap macam tu. Dekat bawah ni pun dia bergetar, dekat atas ni pun dia bergetar juga. Dan getaran tu dia akan menyebabkan energi tu dibuang, okey, ke kawasan sekitar. Jadi contohnya lah, mula katakan dia naik ni, dia menyerap 100. Energi tu katakan 100 lah ya. Kan? 100 kalori lah sebagai contoh. Kalau lah kata 100 kalori sebagai contoh. Sampai dekat sini, okay, bila dia goyang-goyang tu, dia dah buang sebagai tenaga tu kepada haba. Okay, kepada haba. Katakan yang dibuang tu, haba tu adalah 10 kalori. Berapa yang tinggal dalam anda? 100 tolak 10, apa tinggal?
90.
Tinggal 10 kan? Tinggal 10. Jadi kalau 90 ni, terus di-convert kepada fluorescent, agak-agak fluorescent akan appear pada panjang lubang lebih tinggi ke lebih rendah daripada lambda 1? Tadi asal lambda 1 kan? Lambda 1 ni. Okey, sekarang ini tenaganya 100. Sampai dekat atas ni 10 telah dibazirkan dalam bentuk haba, tinggal 90 saja. Kalau 90 ni semuanya dilepaskan sebagai fluorescence, adakah fluorescence akan appear pada panjang gelombang yang lebih rendah atau lebih tinggi daripada lambda 1?
Lebih tinggi.
Lebih tinggi sebab tenaga dia memang dah rendah kan. Bila tenaga rendah, lambda tinggi. Macam tu je lah. Bila tenaga rendah, lambda tinggi. Jadi for sure sebab tenaganya dah rendah dah, sebab tenaganya dah semakin rendah, tidak mungkin untuk dia appear pada panjang gelombang yang lebih rendah. Betul tak? Sebab kalaulah tenaganya tinggi, kalau dia appear pada lambda lebih rendah, lambda lebih rendah tu maknanya tenaga lebih tinggi, which is tak mungkin lah sebab tenaga dia dah rendah. Macam tu. Jadi dia dah appear dekat sini, jadi kalau dia terus dia tukar jadi fluorescent. Tapi kadang-kadang sebelum tukar jadi fluorescent ni, dia akan pergi, ini okey, contoh yang inilah. Kalau S2 ni, kan? Dia sebelum dia turun ke lambda, sebelum dia turun ke ground state, dia mungkin akan turun ke S1 dulu. Kan, dengan dia membazirkan tenaga dia. Mana tenaga tu dia pakai sebagai relaxation. Dia akan relax, okay, turun daripada S2 kepada S1 dan tenaga tu akan dibazirkan. Maknanya akan ada tenaga dihilang. Kalau tenaga dia adalah 10 contohnya kan. Tadi kita kata daripada 100 jadi 10. So daripada 100 hilang 10 jadi 90. 90 kalau dia ditukar dari fluorescent terus, okay, dia akan appear still pada panjang gelombang yang tinggi. And then untuk phosphorescent, dia kena cross. Okay, dia kena cross daripada singlet kepada triplet. Crossing ni juga memerlukan tenaga. Okay. Contohnya tenaga ni adalah 30 kalori contohnya. Kita ada tadi 90 tolak 30 apa tinggal?
60.
60. Okey, jadi bila 60 ni akan ditukar sebab dia sekarang dah dalam keadaan triplet. Jadi dia tak panggil fluorescent lah, dipanggil sebagai phosphorescence. Okey. Jadi dengan 60 berbaki ni dia akan turun ke ground state dan akan dibebaskan sebagai phosphorescence. Jadi 60 tenaga ni for sure dia adalah jauh lebih rendah berbanding dengan tenaga yang 100 mula tadi. So sebab itulah dia akan appear pada lambda 4. Dan lambda 4 ni mestilah dia lebih tinggi. Okay, lambdanya berbanding dengan lambda 1 tadi. Jadi sebab tu tenaga phosphorescence ini adalah lebih rendah berbanding fluorescent ataupun tenaga fluorescent lebih tinggi berbanding dengan phosphorescence. Okey, panjang gelombang untuk phosphorescent lebih tinggilah panjang gelombang dia sebab tenaga dia rendah berbanding dengan panjang gelombang untuk fluorescence. Faham tak anak anda? Farah, faham ke tak? Ya, Afiq dia faham. Lepas kau soal tak faham, siap Afiq. Okey, Farah, can you follow? Alright, okay, so now Ayanda pergi ke video yang kedua lah ya. Oh, ada masa kan? Sekejap. Ini pasal spektrum. Anda boleh follow ke video tu?
Video ni ada suara ke Ayanda?
Ada suara.
Oh,
Sebab dekat Ayanda punya iPhone tak keluar langsung. Boleh dengar tak?
saya tak dengar suara Ayanda.
Tapi videonya nampak.
Videonya berjalan.
Okey, sekejap ya. Ayanda try lagi sekali. Share. Stop sharing. Share lagi sekali. Okay. Is it okay now?
The basic fluorescence properties of a fluorophore, excitation and emission, are often presented in the form of line graphs. These curves describe the likelihood that excitation and emission will occur as a function of wavelength and provide important information about the expected behavior of the irradiated fluorophore. Understanding the information is an important step in understanding the phenomenon of fluorescence. A fluorophore is excited most efficiently by light of a particular wavelength. This wavelength is the excitation maximum for the fluorophore. Light with a wavelength near the excitation maximum can also cause excitation, as shown by the shaded areas, but it does so less efficiently. Fluorescence emission behaves in a similar way. The fluorescence output of a fluorophore is most likely to occur at a particular wavelength. This wavelength is the emission maximum for that fluorophore. The excited fluorophore can also emit light at wavelengths near the emission maximum, as shown. However, this light will be less intense. It is important to remember that although illumination at the excitation maximum of the fluorophore produces the greatest fluorescence output, illumination at lower or higher wavelengths affects only the intensity of the emitted light. The range and overall shape of the emission profile are unchanged. As this animation shows, less efficient excitation can occur at wavelengths near the excitation maximum. However, the intensity of the emitted fluorescence is reduced. Notice that the emission maximum for the fluorophore is always at a longer wavelength, that is, has lower energy than the excitation maximum. This difference between the excitation and emission maxima is called the Stokes shift. The magnitude of the Stokes shift is determined by the electronic structure of the fluorophore and is a characteristic of the fluorophore molecule. So, what causes this energy loss? The Stokes shift is due to the fact that some of the energy of the excited fluorophore is lost through molecular vibrations that occur during the brief lifetime of the molecule's excited state. This energy is dissipated as heat to surrounding solvent molecules as they collide with the excited fluorophore. In summary, the excitation and emission spectra of a fluorophore contain important practical information about what wavelengths of light we need to supply and detect in order to use that fluorophore effectively. In addition, excitation and emission spectra must be examined carefully when choosing two or more fluorophores to use simultaneously in an experiment, so that the fluorophores can be excited in a manner that will generate distinct emissions.
Okay, actually from here, what I want
And
to
emission
know
spectra
basically
must be examined carefully when through molecular vibration. So, shift. The energy, the emission of the emitted, the excitation is less efficient.
Okay, Nanda, ini yang penting kat sini, animation ni. Jadi dia sebut, okay, maknanya regardless kalau kita excite, pada different wavelength, tapi as emission tu is going to appear at the same wavelength, okay, cuma intensity ni berbeza, okay, so you can see from here lah.
Though illumination at the excitation maximum of the fluorophore produces the greatest fluorescence output, illumination at lower or higher wavelengths affects only the intensity of the emitted light. The range and overall shape of the emission profile are unchanged. As this animation shows, less efficient excitation can occur at wavelengths near the excitation maximum. However,
okay, so nampak actually, bila kita tukar wavelength, okay, masih garis berjalan, bila kita tukar wavelength, so, I mean, the emission ni masih lagi, they still happen at the same wavelength. Okay, the only thing, the intensity actually, is changing. Okay, itu je. So, that actually one of the characteristic, of the of the emission. Ini satu sunatullah lah, basically, you know, sifat dia begitu.
Maximum. However, the intensity of the emitted fluorescence is reduced. Notice that the excitation and the of the fluorophore and is a characteristic.
And the other thing under, you know, the Stokes shift here. Stokes shift ni actually the difference between, you know, the emission peak and also the excitation peak. You know, I mean the nanometer. Okay, the wavelength different here. Okay, and the reason like been explained just now. Okay, in fact I pun dah explain that.
Energy loss.
Okay, ini
The
adalah
Stokes shift is due to the fact that some of the energy of the excited fluorophore is lost through molecular vibrations that occur during the brief lifetime of the molecule's excited state. This energy is dissipated as heat to surrounding solvent molecules as they collide with the excited fluorophore.
Alamak, hilang pula dah. Okay, anak dah. Actually, ini what I've been trying just now. Okay. So this Stokes shift basically because of, you know, the energy. I mean, the Stokes shift actually basically giving, you know, the difference, okay, in terms of the wavelength, okay, between the emission peak and also the excitation peak. But this can also be inferred, you know, I mean the energy, okay, that been lost, okay, once the emission occur. And this basically because of, you know, like you can see from here. When we excite, you know, the molecule, I mean, the excitation is going to occur, like been shown, you know, in the blue line here. And then, you know, during the excitation, you know, at the excited state level, I mean, some energy, okay, will be released in the form of heat. So, actually, heat is being released. So, energy has been wasted, okay, more or less, because of the molecule actually is having, you know, some vibration, okay, and maybe collision as well, vibration. And then maybe collision, you know, with other molecule as well. So as a result, you know, the energy decreasing, you know, from this point, okay, up to this point, okay. And finally, after that, you know, I mean, the energy will be released in the form of fluorescence, okay. So any question anak you want to ask, okay, regarding this, okay, regarding the videos? Ada soalan? Nanti Anda tanya soalan, dia kalau tak ada soalan. Any question that you want to ask? Okay, so maybe I'm going to show you another video. Okay, ni I'm hoping, okay, once you going back, okay, so try to study, okay, this thing. Okay, this is very important, the Jablonski diagram.
Hello everyone, myself Zilbert and welcome to my channel Zil's Pharmacy Tutorial. And today we are going to study about Perrin-Jablonski diagram. When the energy is supplied to the electron in the form of light, they absorb the energy and reaches to the excited state. In the excited states, electrons are very unstable and hence they try to get back to the ground state. The process by which they get back to the ground state is known as relaxation, and the process by which they absorb the energy and reaches to the excited state is known as absorption. Now, as per Perrin-Jablonski diagram illustration, there are multiple pathways by which the absorbed molecular energy can be released. Relaxation can occur in many ways. The process of relaxation mainly occurs in two ways. First is radiative way and non-radiative way. In the radiative way, it occurs by two mechanisms. First is fluorescence and second is phosphorescence. Before we study about the mechanism of fluorescence and phosphorescence, let us see what is singlet state. A state in which all the unpaired electrons have opposite spin. Here both the unpaired electron in the ground state have opposite spin, thus it is known as singlet ground state. Now here, the unpaired electron in the ground state have the opposite spin as that of the unpaired electron in the excited state. Thus it is known as singlet excited state. Now what is triplet state? A state in which unpaired electrons have same spin. That is, the unpaired electron in the ground state is having the same spin as that of the unpaired electron in the excited state. Thus, this state is known as triplet state. Let us have a look on the Jablonski diagram. When UV light is absorbed by an electron, they get excited, and from the singlet ground state, they reaches to the singlet excited state. Over here the electrons are very unstable and hence they try to get back to the singlet ground state. So this process of relaxation occurs in many ways. So the first way is the non-radiative transmission, in which the electron shifts to the lower electronic level without radiating any radiations. The second way is the internal crossing, in which there is transition from the higher electronic level to the lower electronic level. The third way of relaxation is the radiative way, in which there is transition from the singlet excited state to the singlet ground state, and it is known as fluorescence. Another way is the intersystem crossing, where there is transition between the two isoenergetic vibrational levels having different spin multiplicities. The state during this transition is the triplet state, and when there is transition from triplet state to the singlet ground state, it creates phosphorescence. It is also a radiative relaxation. So this was all about Jablonski diagram. Now let us have a look on the key terms which are included in Jablonski diagram. So the first is fluorescence. It is the phenomenon of emission of radiation when there is a transition from singlet excited state to the singlet ground state. That is, when the transition occurs from the singlet excited state to the singlet ground state, there is emission of radiation. The another term is phosphorescence. It is the phenomenon of emission of radiation when there is transition from triplet excited state to the singlet ground state. That is, when there is transition from triplet excited state to the singlet ground state, there is again an emission of radiation which is known as phosphorescence. Now, the another term is the internal conversion. Transitions from the higher electronic state to the lower electronic state is called internal conversion. In this transition, no radiations are emitted. Now, the last term is intersystem crossing. It is a non-radiative transition between the two isoenergetic vibration levels belonging to the electronic states of different multiplicities.
Okay, Hananda, actually this is giving you, very good perspective, on what we explained earlier. Okay, so basically, I mean the diagram that we discussed just now, it is called Jablonski diagram. Bukan Jabon, sebut betul-betul bukan Jabon. Jablonski diagram. Alright. So actually the person that trying to explain what happening by merely showing the diagram. So I think in the latest video just now, if you see, the Jablonski diagram, I think it's been explained very clearly, even though it's just merely handwritten. So you can differentiate between inter-system crossing, like what we mentioned just now, and also internal crossing. Okay, intercrossing itu makna dia within the same singlet state. Okay, dia tidak ubah apa ni, tidak pergi ke triplet state. Okay, and finally, I want to show you the last video, and the rest I'm really hoping that you going to look at it. So maybe I will put a slot there. I'm going to give you maybe 24 hours for you to go through the rest and come up with some what you call it I mean the what you call the apa ni mind maps ataupun tadi itu infografik sebab tak sempat nak tengok. Dan please ask me if you don't have if you have anything that you want to know about. Okay, finally I want to show video which is very good on the quenching.
Hello everyone, myself Zeel Bhatt and welcome to my channel Zeel's Pharmacy Tutorial. And today we are going to study about quenching or quenching effect. So first of all, what is quenching? It is the decrease in fluorescence intensity due to specific effects of constituent of solution itself. Thus, quenching effect decreases the fluorescence intensity. So now, what are causes of quenching? It may be due to various factors like concentration, pH, presence of specific chemical substance, temperature, or even viscosity. Now, let us see what are types of quenching. There are 4 types of quenching. First is concentration quenching, then chemical quenching, then static quenching, then dynamic quenching. Now let us see in detail what is concentration quenching. It is caused by excessive absorption of either primary radiation or fluorescent radiation by solution itself. This is also called inner filter effect. And sometimes if there is absorption of fluorescent radiation by substance in the solution itself, then it is called self-quenching. Now let us see what is chemical quenching. The quenching which occurs as a result of change in the chemical nature of the fluorescent substance is called chemical quenching. It can be due to change in pH, presence of oxygen, presence of halide or electron withdrawing group, or presence of heavy metals, etc. Now let us see what is static quenching. It occurs due to the complex formation between the quenched and fluorescent molecule at ground state. It occurs due to the strong coupling. This diagram represents static quenching. This is a fluorescent substance, and with the complex formation with the quencher Q, it causes quenching and thus light cannot be emitted, which is the fluorescent radiation. Now let us see what is dynamic quenching. Dynamic quenching is just opposite to static quenching. It occurs at the excited state. In the dynamic quenching, there is weak coupling between fluorescent substance and a quencher. There is a collision between fluorescent substance and quencher.
Right, okay, that's what I done with that. So basically from this video,
this was all about quenching. Do not forget to like, share and subscribe if you have really enjoyed my video.
Alright, okay, from this video, basically you can differentiate, different type of quenching. And quenching is basically a phenomenon, the phenomenon that's going to occur during fluorescence, that's going to reduce, the fluorescent intensity. Okay, so just now they mentioned about the concentration quenching. Concentration maknanya kalau larutan tu terlalu pekat. Seperti you prepare quinine tu kan pekat sangat. Okay, so dia akan ada self quenching because bila pekat sangat, there's too many molecules that molecules going to collide to each other, and during the collision tu energy will be wasted. Okay, and then they're having chemical quenching. Chemical quenching ni actually because of the chemical parameters. Okay, chemistry punya parameters, pH, maybe heavy metal, okay, they're present, okay, maybe oxygen actually is quencher. All this is going to reduce, the intensity of the fluorescence or the phosphorescence. And I mean, also giving, the difference between the static quenching, which normally happen, at the solution, at the ground state level, okay, whereas the dynamic quenching normally occur, at the excited state level. Okay, Nanda, so I think I'm going to stop here. Okay, very sorry because I need to take, 2 hours straight, okay? Because of, I think maybe your understanding is not that very clear on the fluorescence, next week, I'm going to focus on the NMR, okay? But I think for the fluorescence, yeah, actually it's not complete yet, the information. So I'm going to I mean, the link already there, but, I'll put in the assignment, okay, instruction, okay, for you to do the, what you call it, to do the mind maps, okay, and infographic. Maybe I will put, some guide in there so that, you know what you need to put, in the infographic or maybe your mind maps. Okay, Nanda? So I think that's about all, okay, for today. Hoping, okay, to see you again next week, insyaAllah. Okay, Assalamualaikum warahmatullahi wabarakatuh. Sudah dengan tasbih kifara dan surah Walas. Bismillahirrahmanirrahim. Ya, nak ada. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih Ayanda. Jumpa lagi.
Welcome.
Ayanda.
Okay.
Thank you, Ayanda.